Hello everyone. In this video we're going to learn about graphing linear functions using what is known as slope-intercept form. Alright, on this slide we're going to take a look at a line that has already been graphed for us. We're going to investigate a little bit. This is one of those things that doesn't really translate well to videos, but would have been an activity that we covered in class. So if we notice on the line, what we've talked about in the previous week is calculating slope between any 2 points. So let's go ahead and do that. As a reminder, slope is constant for linear functions, meaning it doesn't really matter where I look. If I look between point A and B, between point B and C, or even between points A and C, the slope, while seemingly different, is actually going to be the exact same thing. When I say seemingly different, it might just simplify further and ultimately work out to the exact same constant slope. So let's go ahead and pick any 2 points. Just for clarity, I'm going to go ahead and pick point B and C. So if we calculate the slope here, and I highlighted the points just because it was a little unclear what their exact coordinates are. It looks like we rise 1, remember rise over run, and then we run twice. So what is the slope of this line if we consider this as a ratio, change in y over change in x, or rise over run? The slope of this line is going to be 1/2. And very quickly, let's say you chose the furthest 2 points, points A and C. That would be a vertical change of 1, 2, 3, plus 3, and then a run of 6. So same thing, 3 over 6. That's what I said. Looks different at first, but what is it going to boil down to? Also 1/2. So we have the slope of this line is 1/2. Now, this is going to be a new vocabulary word today. Point B is an important feature of this graph. It's where it hits the y-axis. Remember, we've talked about the x and y-axis. The point where a graph hits the y-axis, we refer to as the y-intercept. Let's kind of write down what we know so far. We know the m value is 1/2. That's our slope. And then the y-intercept. Intercept means like basically, hey, where does this line hit the y-axis? Occurs at -3. The x value on the y-axis is always going to be 0, so you don't have to say, 0, -3. You simply just say whatever that y value happens to be. So the y-intercept is -3. Now, what was the whole point of this slide? Let's go back to the original equation that was actually graphed, the actual red line that's graphed here. The equation is y equals 1/2 x minus 3. So what connections do you notice here? You should notice that, hey, the slope of this line was 1/2, and that also happens to be the coefficient, the number in front of x. The y-intercept was -3, and that happens to be the constant on the end. And as we'll see later on in this lesson, this is not a coincidence. This is not random. This is always going to happen with lines, and this is what we know and refer to as slope-intercept form. All right, some notes you can jot down. These stars on this slide, everything with a star in front of it, if you'd like to copy it down, good idea for referencing later. So slope-intercept form is what we call y equals mx plus b, where m, we've already seen this, so hopefully this is familiar. M is our slope, and b is our y-intercept. Once again, y-intercept, and I also defined it for you. The y-intercept is the point where the graph hits the y-axis. So if we look at that mini graph on the right-hand side, it looks like the y-intercept, or b value, which we'll write down, is going to occur at 4. Once again, for b, we just kind of announced the y value. We don't really care that x is 0. It's always going to be 0 on the y-axis. So the b value here is 4. Now, slope-wise, let's use that same y-intercept as our starting point. Remember, we moved from left to right. Slope-wise, it looks like we're rising 1, and then we run, count 1, 2, 3. So we rise 1, we run 3. That would be a slope of 1/3. Okay, so if we put these two ideas together, the equation of this line, even though we can't actually see it, we know it's going to be y equals 1/3. Remember, the slope goes in front of x like a coefficient. 1/3 x plus 4. If you're curious, is it always going to be plus something? Let's say the y-intercept happened to be negative, like the last slide that we just saw. Instead of putting plus, let's say, -3, you would just simply write -3, or you can just simply write -3. Now, a very, very important aspect with this whole m and b idea, or like, oh, coefficient of x and the constant, only works when the equation is in y equals form. Y equals, okay? So if the equation looks like this, 3x plus y equals 10, we can't just go, oh, the slope is 3 and the y-intercept is 10. Or if there's a number in front of y, let's say. So sometimes you might have to do some maneuvering in the beginning to identify what m and b are. And ultimately, we haven't even gotten to this yet. We're going to use this to help us graph. If you're curious, are we just using this to pick out kind of pointless information? No, we're going to use these two pieces of information to help us ultimately graph lines a lot faster than making a table. But closing this slide out, let's take a look at this example. So we said we can't just kind of pick out the m and b values right now because it's not in that y equals look. It's got to be y equals something. So it's pretty close to being y equals. I basically kind of want to get rid of this part of it. Not get rid of it, but move it to the other side. So how do we do that? If I want to move that 3x to the other side, I'm going to subtract it. Now, subtracting it on the left is going to cancel it. And since it is an equation, whatever I do to one side, I do have to do to the other. So I'm going to subtract 3x on the right-hand side as well. Now, I have the y equals that I wanted on the left, because remember I canceled out the plus 3x. And now I have the negative 3x on the right. Remember, I can't combine 10 and 3x to say, let's say 7x. They're unlike terms. One is a number, one is a variable. So I'm just writing them separately. You could similarly write 10 minus 3x if you want. I usually like to put the x before the constant because that's how slope-intercept form usually looks, or traditionally looks, the mx plus b. So now that it's in y equals form, we can pick out our two pieces of information. We'd say, hey, the slope is -3. The y-intercept is 10. All right, and we'll finally see how this whole idea of slope-intercept connects to helping us graph. So in this case, we're given the equation 2y equals 6x minus 8. So the first thing that I'm going to do, remember, I cannot pick out the slope and y-intercept right now. How come? Because it's not in y equals form. So what do I have to do in this case to get y by itself? Well, there's a 2 in front of it, so I'm going to divide the left side by 2, and I'm going to divide everyone on the right side by 2 as well. You could similarly just put a larger fraction and write 2 on the bottom on the right-hand side. I like to kind of do it separate sometimes so you don't forget. And that's going to give us the y that we desire, 3x and minus 4 now. Now that it's in y equals form, we can pick out the slope. And I'm going to explain this when I get to the graphing part. Instead of writing 3, I'm going to write the slope as 3 over 1, which is obviously equivalent to 3. And you might be saying, what's the point of writing something like that? You'll see when we get to the graphing stage. The y-intercept, be careful, it's not 4. It's actually going to be -4 here because it does say -4. For it to be +4, or for it to be just +4, it would have to say +4 in the equation. Okay. Now the steps are in the top left. Once again, if you'd like, you could jot them down. There's a little, not trick to this, but a way of you remembering it, almost like an acronym. And these are not where the letters come from, but for M and B, the B value, once again, our y-intercept, tells us where to begin. So your B value tells you where to begin. So that's the first point that you're going to put on your graph, is going to be the y-intercept. And obviously, it's going to be on the y-axis. So we're going to plot our y-intercept at -4. 1, 2, 3, 4. So your B value tells you where to begin. Now your slope is going to tell you how to move. And this is where the 3/1 came from. Remember, slope is rise over run. So if I want to go from this point I just plotted to the next point, I'm going to go up 3, 1, 2, 3, and 1 to the right. Basically, you're kind of counting off, hey, I go up this many and I go right this many. Or if it was negative, I go down this many. So I'm going to go, I could do this as many times as I want as well. 1, 2, 3, 1, 2, 3. I lost my point. 1, 2, 3. You don't have to do this 50 times because if you were graphing this on paper, you would simply just use a ruler after maybe 2 or 3 points, but you can do it a little bit more. If you'd like, it makes connecting a little bit easier. And then once you have a few points, you'd use a straight edge to connect it as nice as you can. And as always, we put arrows on our lines to indicate this line or this relationship extends forever. And good habit to get into, particularly when you get into more advanced math classes, labeling your graphs. Sometimes you'll have more than one example on a page, so it's a good idea of saying, hey, this is this graph, or this is the equation of this graph. Okay, so summing up what we did, we plotted the b value, that's where we began, and the slope tells us how to move. So going back to the 3/1, it's a good idea if your slope is a whole number to write it as a ratio over 1, or as a fraction with a 1 in the denominator. People just beginning out with this topic, if they write the slope as 3, might simply just keep rising 3 and have a vertical line. So the 1 is kind of a reminder, a placeholder, that you should be kind of ticking 1 to the right every time you go up 3. If your slope is a fraction, you don't have to worry about doing this. Let's say your slope is 2/3, you would go up 2 over 3. But if you do have a whole number, it's a good idea to put it over 1 to remind you to go to the right. All right, and we'll try one more example. So we're going to graph 2x plus 3y equals 9. First thing that I'm going to do, get it in y equals form, get y all by itself. So I'm going to move the 2x to the right first by subtracting it. Once again, I like to put it in the beginning. You could write 9 minus 2x if you wanted to. You can combine them. You can't say 7x, but I like to put it in the beginning. Okay, now I still have a 3 in front, so I'm going to divide everybody by 3. That gives me y equals, don't panic that you have a fraction. These are actually desirable with slope. We like fractions. That's going to be negative 2/3. Just leave it as that. Don't put a decimal. You can simplify it if you can, but leave it as a fraction. And then plus 3. Work-wise, all we have to do for slope-intercept is literally write down what the m and b values are. So you can compare this with making a table of values. This is obviously a lot faster, especially once you get the hang of it. Now we're going to begin with the y-intercept, which is 3. So that's my first point on my graph. I'm going to go up 3, put a dot. Silly mistake that a lot of people make, plotting the y-intercept on the x-axis for some reason. There are techniques where you do use the x-axis. That's standard form graphing. But for now, if we're plotting the y-intercept, it's called the y-intercept. It should always be on the y-axis. And now let's go to our slope to figure out how to move. Since the slope is negative 2, instead of me going up 2, I'm actually going to go down 2 and then right 3. Down 2, right 3. And the only thing that kind of gets negated here is the rising. We're always going to run to the right. Remember, we talked about this in the slope lesson. If you go down instead of up, you indicate that with a negative in your numerator. Basically, it just makes the fraction negative. But some people do make the mistake of also like thinking that the run has to change. You're always running 3 to the right here. If you want, let's say some more points up here, maybe it's an example where you can't fit a lot of points this way, you can work backwards by doing the exact opposite of what we just did. We can go up 2 and then 3 to the left. You don't have to do this, but like I said, maybe if you want some points in the opposite direction, you can kind of backtrack. Okay, once you have a few points, nice smooth line between these, arrows on both ends, and that's our line. So this is graphing using slope-intercept form. We're going to practice with this for a day or two to get the hang of it. Hopefully you are already seeing that it is much more efficient than graphing using a table of values. While that is important, this is the more traditional, the more common way that people end up graphing linear functions. Let me know if you have any questions, comments, or concerns, and thank you for watching.